Let us now try to apply the same idea with the error in the measurement in identifying where the tip of a tooling robot will be located. So I'm going to redraw a tooling robot. Again, remember we are working on a plane. We have a tooling robot that has lengths L1 and L2. You're already seeing this angle alpha 1 and angle alpha 2. And we've seen the expressions that XE is equal to L1 cosine alpha 1 plus L2 cosine alpha 2. And YE equals L1 sine alpha 1 plus L2 sine alpha 2. If now we have an error in our measurement where alpha 1 has an error delta alpha, so we'll have plus minus delta alpha, and alpha 2 has an error plus minus delta alpha. So here we assume that both errors in positioning in rotation are the same. Then we will have an expression for the position in this tip as XE equals to L1 cosine of alpha 1 plus minus delta alpha plus L2 cosine, here we have alpha 1 plus alpha 2 on the cosine and alpha 1 plus alpha 2 on the sine. Apologize for that. So this will be going back. We have XC plus L2 cosine alpha 1 plus minus delta alpha plus alpha 2 plus minus delta alpha. And YE is going to be similar expression. And of course, now we can try to understand how to draw this if we understand the analysis using these trigonometric identities. So the first link will be, again, I'm not considering an error in the fabrication. So if this link rotates an angle alpha 1, then we, similar to the previous example, we can identify these 2 points which will be on this arc. At these 2 points then, we are going to put and draw link L2. And now this link has, when it's positioned, let's say over here, has an error in positioning the rotation due to alpha 2 of this much. So now this guy is going to be anywhere on an arc that goes from this point and it has a length of L2, and then it could be anywhere on an arc on this arc here. So now we observe that if L1 is at this, if the rotation due to positive theta 1 gives us this point, the rotation due to negative alpha 1 gives us this point, then our linkage will be anywhere on a surface that will be given by points that are at the minimum and maximum of these two arcs. So as an exercise, you will have to identify XE and YE given the values for L1 and L2. L1 is 50 millimeters and L2 is 40 millimeters. And alpha 1 is 30 degrees, alpha 2 is 45 degrees, and delta alpha, let's say, is 1 degree. So you need to identify all the points that the discrete points at the extreme values for this particular tooling robot. And once you identify that, you can also find the expression that considers error in the fabrication for L1 and L2. And of course, if you do this, you recognize that the expressions become so complex that are tedious to analyze.